Very good morning, everyone. So now we'll start our today's session. So for this, I would like to request Professor Florette Dakhar, Principal, NERIE, to kindly escort today's keynote speaker, Professor G. Ravindra, on the dais. And I will request Dr. Tulika De to escort the chairperson of today's session, Shri Professor Anup Rajput sir. So first of all, I'll request Professor F.G. Dakhar just to extend warm welcome to today's session.
A very good morning. We're happy to see you again on the second day of this national conference. I hope you, with the smiles that I see on your faces, I hope everything is right. Right? Okay. All right. We are very happy that today is the second day of this national conference, and we have with us our former director, Professor G. Ravindra, and sir is kind enough to be the keynote speaker because this is a general session that we are having. I need not introduce sir again because that will be done later. But again, sir, I thank you. And he was there right on time. We had a long talk in the morning. It just shows the kind of interest that he has, you know, with the work that we are doing and every time motivating us, inspiring us. So with this, sir, I thank you so much. Professor Rajput, thank you so much for being the chairperson of this session which we are going to have today. And to the two conveners here, I wish them the very best. And to each one of you, okay, let us be a day where we will continue to learn more, and the learning that will take place today, it will further help us to have a new vision, new insights, new inspiration in the work that we are doing wherever we are. So with these few words, I welcome each one of you, and yes, the faculty members, everyone who are here to this session, and I wish the day a big success. Thank you.
Thank you, Madam, for extending the warm welcome. And now, to begin the session, before starting the real session, so I would like to request Professor Anup Rajput for introduction. But before that, I will just say a few words about sir. So Professor Anup Rajput is in the Department of Elementary Education, NERIE-NCERT. And then now he is heading the Department of Publication since last 4 years. So without taking much time, I'd like to request Professor Anup Rajput sir to kindly introduce Professor G. Ravindra sir, today's keynote speaker. Please, sir.
Thank you, and very good morning to all of you. Weather is very fine here in Shillong. We are enjoying it better than Delhi.
Oh, good.
No, it is excellent. Because in Delhi we are having a lot of, say, pollution, and severe cold and many other things. But life here is very charming. We are enjoying our stay here, and everything is very, very nicely organized. Thank you to the Honorable Principal of this organization, this institute, for arranging all these things so nicely. And for this conference, obviously we all are enjoying. Last day we had very good time, and we had good sessions wherein we all had learning from each other. Today also it will be continued, but this is another opportunity wherein we are having renowned mathematician of India who remained with NCERT for many years and is still working in other institutes also. So I'll give you a detailed account of our today's keynote speaker, Professor G. Ravindra ji. Professor G. Ravindra ji is former director of NCERT. He was joint director of NCERT and then director of NCERT. Also, he did his MSc from Karnataka University, Dharwad, and then PhD from IIT Madras and postdoctoral from University of Paris in 1978-79. During his stay, he joined NCERT in 1976 and worked for more than 34 years in NCERT. He has a wide experience of teaching, research, extension, training, and many other aspects of NCERT, including the good educational administration. He has teaching experience of 30 years to undergraduate, postgraduate classes, particularly teaching MSc, guiding students for PhD, which he still is continuing. He has 45 research papers to his credit, which he wrote and published in national and international journals. Many of them are published in very renowned journals. He has done his research on geometric algorithm and combinatorial optimization. Also, including this, he has lot of work which he is doing, being member of many societies and organizations like American Mathematical Society, Ramanujan Mathematical Society, Asian Institute of Human Rights Development, National Steering Committee for NCF 2005, National General Body of WCERG, National Focus Group of of Systematic Reforms for Curriculum Changes, National Advisory Committee for IIT Mumbai, and Governing Body and General Body of Vigyan Prasar, National Advisory Committee of Kishore Vigyanik Prosan Yojana, Steering Committee of National Science Academy, Bangalore. And along with this, many other leadership roles he has played. He has been an instrumental part in development of curriculum and syllabi for pre-service and in-service teacher education programs, particularly with NCTE. He developed program for BSc B.Ed, an innovative program, then MSc Ed and B.Ed. While he was working in Regional Institute of Education as principal here in Mysore. As principal of Regional Institute of Education, Mysuru, he has established also in Bhopal, he has established very close link with states and other organizations in the state, including the boards of school educations, universities and other organizations. As joint director, he has played a very good leadership role in NCERT, was instrumental in making NCERT an organization which had a say. While 2005 curriculum was developed, he was there, and then textbooks were written and many other things were developed under his guidance as he was joint director, when he was joint director there. He has done lot of programs, particularly to enhance the teaching learning of mathematics. One of them is an innovative program of Government of India, which was under Samagra Shiksha Abhiyan, and there were two programs launched. One was group arithmetic, which he chaired for many years, and there was another program which was named as Reading Cell, but down later that was named as the Department of Literacy Reading. And this group arithmetic program is still continuing. He has developed lot of material for teachers, for teacher educators and others. He has visited many countries, as I mentioned, but being leader in NCERT, having the position of joint director and director NCERT, he has visited many countries and developing a liaison between NCERT and parallel organizations in other countries, which include Frankfurt. He was there for book fair, Kuwait, monitoring distribution of NCERT textbooks, United Kingdom as chairperson of senior management team, visited Shanghai to deliver a lecture on monitoring for management of quality education in a conference. Then he was convener of National Children's Science Congress, 1997, and so on. So he has lot of things, and I will not be now taking much time in between you and Professor Ravindra. Professor Ravindra is a renowned person, as I mentioned, not only in mathematics but in mathematics education also. So he will be talking to you on various aspects of mathematics education, including the today's practices which are going on and the future perspective which we have. I will request all of you to please write down your comments and suggestions if you have and your questions, and you will be given time. After this depends on Professor Ravindra ji. If he allows, you can ask in between also, but I will prefer you keep on writing your questions, and some time will be given to you to talk to Professor Ravindra maybe after his deliberations with you. So thank you, you came here, and thank you very much, sir. You are here, and we expect that we will be having a fruitful session with you, wherein we all will be having good learning, particularly in the present perspective and in the scenario when we are going to have new national curriculum framework, new material which is going to be developed, particularly for school education. I welcome you, sir.
Thank you, sir, for the your presentation on the Professor G. Ravindra's biodata, detailed biodata, and you have mentioned right from as a teacher, as a professor, and as a administrator in the NCERT, and the sir's involvement in different arena of the education like mathematics, and then not only mathematics, other educational aspects also. And now you have mentioned that sir is still continuing. So sir is very vibrant, and thank you, sir, for giving a good introduction about the today's keynote speaker, Professor G. Ravindra sir. So now I would like to request Professor G. Ravindra sir to deliver on the topic today's that address connecting Indian pedagogy containing concentration, feelings, aesthetic, dynamic experience to mathematics education. So, sir, I request you, please to deliver and take your time, and the platform is yours now.
Professor Dakar, the principal of this institute, Professor Rajput, who is the chairperson of the session, Professor Devi and Dr. Tulika, and my friends, Dr. Pradhan is here, and Dr. Subhash Chandra Roy, and Ashwini Prasad is there. So many my colleagues. Yeah, I keep meeting them now and then. So now today I'm meeting them. I have my student here, Kritika. She's here. Kritika, she did her MSc Ed and MEd from Regional Institute of Education, Mysore. She's a bright student. She's doing her PhD in Central University, Kasaragod, on mathematics education. So let me thank profusely the principal and Tulika for giving me an opportunity to be here and say something on mathematics education. Before I say something, let me have a definition of a teacher. A teacher speaks truth. A teacher communicates truth. A teacher practices truth. I think if that is done, nothing like it. We don't need a government at all in this country. The teachers would manage everything. But the truth is one thing, is the most important thing, and the most difficult also. And the entire mathematics is built on truth. In mathematics, we say mathematics is a study of sets. Set is a property which is either true or false. That happens only in mathematics, nowhere else. A property which is either true or false, only in mathematics. So that is what you have only one thing, and that's exactly the truth. So all theorems, all properties, whether in mathematics, outside, if they follow truth, they're coming closer to mathematics. We have in science, but science, many of the results are approximations. Almost all results in science are by experiment. If there's any exact result, then it's essentially a mathematical result. So the today's talk, as told by Professor Devi, I will be going to talk on connecting this age of connection. Once we had an age of constructivism, but now people are not talking much about constructivism. People are talking more about connecting. I think connecting is the one which stays for a longer time. I think if you are in this room, we are all connected. There is a connection. So, connecting Indian pedagogy. By Indian pedagogy, I don't mean that it's not in other countries also. There is the Chinese pedagogy, there is an American pedagogy, there is a Greek pedagogy. All pedagogies are connected. So connecting Indian pedagogy, containing 4 important things. I spoke about 3 components in the last Ramanujan conference at RIE Bhubaneswar, but I have added one, that is dynamic experience. So we have concentration, we have feelings, we have aesthetics and dynamic experience. These are the 4 aspects which are connected to mathematics education. I think this 3-page thing, hope you will be getting soon. I think if it is there with you, it's fine. So, before I come to the exact things, let me look at education also. My education is only by experience, and whatever I have written here, it's all based on my experience. Education, I don't have B.Ed degree, I don't have M.Ed degree. I'm just a mathematics teacher. But my understanding of education is my experience in NCERT, 34 years. For me, education is essentially set of values. Values which need to be practiced, not just preached. I think many of us, especially the politicians, they keep on preaching. Preaching won't work. The practicing will work. Even sometimes preach and practice also is okay. And practice and practice is the best. So, there are many, I think, NCERT and even United Nations, UNESCO, they have identified more than 100 values. NCERT also has done a lot of things on the values. I think one of the most important values which I chose, living together. Living together, I think in the present context is very, very important. By living together, I mean patriotism. Those days, patriotism was fighting against the British. But nowadays, patriotism is we'll have to live together and avoid hatredness. And this is most relevant. I think this hatredness will never work. And it's not part of education. In fact, education is positive. I think this was told to us when Professor Rajput, earlier director, and I went to meet Satya Sai Baba Putmurti. I think he told us education is positive. There is nothing called negative in education. So if that is the case, education does not have hatredness. If anybody practices hatredness, that person is not educated, logically. So, living together happily, peacefully. In fact, in 21st century, we will have to live together peacefully and happily. And that is the 21st century message of education. Even loving students. And the most important thing these days for the younger generation, the real value is the optimality. One of the examples of Gandhiji, less I have, more I am. Less I am means I eat only that much which I need. Then I have understood myself. I think it's a big statement of Gandhiji. So less I have, more I am. So this is a good example of optimization, and especially in economics, if you want to improve the economy and all that thing, optimality is needed. There's a subject called operations research, deals with optimization only. Even in graph theory also there are many areas where optimization does work. Even in computers also optimization does work. So now, I think before I go to concentration, let me, there is a Venn diagrammatic approach. It's not, don't look at it in a mathematical way. Venn diagram means seeing the relations. Venn diagram is essentially a region which has no holes, and when they intersect, when they do not intersect, we get this one. But the interesting thing is, this is the real mathematical, this one. That is, given any two statements, P, Q, then what is going to happen is P is Q, means every part of P is Q, and some P is Q, and no P is Q. These are the only three possible relations. Think of thousands of relations, but you can always have only in this one. I think that's the thing which is going to make the relations interesting. And the Venn diagrammatic approach is this. And at the end, I'll show you one figure. I'll try to. So that was the Venn diagram drawn by one student called Jagdish in demonstration multipurpose school in RI Mysore. And all that thing I'll explain will take 2 minutes. So the concentration, the first one is the concentration. I think this is truly in Indian pedagogy. I don't think in many other countries we see this concentration as a pedagogy. See, in a concentration, what happens is when we look at a particular concept and idea, we focus totally. We don't look at anything else, only that particular idea. If I'm seeing something, only at that thing. Like Tendulkar, when he bats, he doesn't do anything else. He'll be only looking at that particular ball. So that's a kind of concentration. But even look at Arjun in Mahabharata, when he did that Matsya Bheda, that fish, he could hit it just at the mouth. So in that Swayamvara. So that's a concentration. Even Ramanujan, there's a beautiful anecdote of Ramanujan. He was ill in a hospital, Putney Hospital also. So Hardy, his mentor, he goes to see him because he was not well. So he tells him the number of the taxi 1729 is a dull number. I think Ramanujan says, no, Hardy, it's an interesting number. This is the sum of 2 cubes, like 10 cube plus 1 something. Yeah, I have that thing. I forget. Yeah. That is 12 cube and 1 cube. Other one is 10 cube and 9 cube. These are the only two ways you can express that number, and this is the smallest number which can be expressed in 2 cubes. I think that's a big thing, and that talks about the concentration of Ramanujan. So Ramanujan, I think he always believed, he used to dream always his deity. I think she was Saraswati Rupa. He always used to dream, and he used to get the ideas only through the deity. And that was the real concentration he used to have. And hallmark of Ramanujan is his intuition. I think he knew very well that he was not going to leave. I think most of his results he has written on the corners of a page, just results. He didn't have time to prove it, but just give some hints and all that thing. He's one of the theta Mach functions. Is very, very famous, and also the value of pi that runs for some 35 numbers. It was used even in computers also. Now we've got better ones. So that's Ramanujan. But let me say that I think if the teachers in the class, they don't have to do much. Allow the students to concentrate on a particular idea and give them some ideas, connect the ideas and do something, concentrate. I think concentration cannot be taught. Concentration is a mathematical value and it has to be practiced, and the students know what to do. The other one is feelings. Feelings do matter. Feelings do matter in mathematics. I think if a student feels for mathematics, he automatically creates some mathematics. Because feeling is the shortest path of learning. Adi Shankaracharya, who was in 8th century, one of the greatest philosophers of this world, who is known for that Aham Brahmasmi. Aham Brahmasmi means you go on correcting yourself, go on correcting, go till the top. So that's the stage you become God. That's what is Aham Brahmasmi. He said that if you feel for something, the job is done. Otherwise, we are lost in a jungle of thoughts. So that shows the value of feelings. And again, feeling is a value which need not be preached. It can only be practiced, and it may not help in teaching, as a value, but you will have to again ask the students to feel. Feeling is that thing. And now come back to that I did do something when I was a principal in RI Bhopal. There was one headmistress called Anshu Srivastav. He took me to the primary school, 3rd standard. So I didn't do anything. I just smiled with the students and gave them some numbers and asked them, I said that how table 2 can be constructed. 2 plus 2 is 4 and 4 plus 2 is 6. Like you have a number k, and k plus k is 2k and all that thing. So the k table is generated. And that idea I gave them, and I just smiled with them, nothing else. But many of the students, they constructed table up to 12th table. One student constructed even 17 table. Not only 17, he did not end up at 17 tensa, 17 11sa, 17 12sa, 17 13sa. I think that is the value of feeling essentially the smile. If the teachers you smile, don't laugh at the students, but laugh with the students, smile with the students. So it does many things. That was an experiment. I conducted a small experiment. I not published it. So, I'll take that example of Venn diagram of Jagdish in the end. Now, coming to the aesthetic, that is the center of my talk. I keep talking, I keep feeling also that aesthetics matters. I think we teachers will have to change our style of teaching, at least for a while. If you bring in some aesthetics, there's no definition, proper definition of an aesthetics, but we know it very well, what is beauty, what is not beautiful. And when we see a sea, like you see that Vadapani lake, so beautiful, and see the entire Shillong hills, oh lovely. So what a beauty. And that is aesthetics. But the real source of aesthetics comes from the infiniteness, infinite collections, like number of stars, or the sky, or Himalaya, the snow-clad Himalaya, and all that thing. So this was a question which I asked many people in workshops. Is the number of water molecules in Bay of Bengal finite? I think majority of the teachers, 100% teachers said, yes, it's finite. No, it's infinite. That was the answer. But it's not infinite. Why it's not infinite is each molecule has a volume. And the sea also has a finite volume, the water molecule. So the finite divided by finite gives you the number of water molecules. So finite by finite is finite. So number of water molecules in Bay of Bengal is finite. That is simple proof. So this aesthetics, I'll give you one example. When I was a student in 8th standard in a government school in Gulbarga, now it's called Kalburgi. So now it's in Karnataka. So there, the government school was called Asifganj School. It was all surrounded by mutton market, so much of this one. But I had an excellent teacher called Gulingappa. He used to teach us Kannada, mathematics, English. And the interesting thing is, very rare such teachers. He used to go to every student and to see whether the students are able to draw a triangle, a circle which meets the vertices of a triangle. I think he gave some proof also for that thing. Such a thing is very rare. Then in the same school, we had a craft teacher called Yusuf. And he was a crafts teacher. He asked me to, the wood and all was available. He said, make 3 sticks and make holes at the end. Then he said, you buy screws from the market. So just 10 paise or so, he got 3 screws. And then I made 4 sticks also. Then what I did was, those ends, I joined them by screws and got a triangle. And also made a quadrilateral also. The interesting thing was, when triangle was there, however much pressure I would apply on the sides, it was not changing the shape at all. But while the quadrilateral, when you do it, you can have infinitely many ways of doing it. I didn't get the answer because I was 7th standard. When I came to 8th standard, we had a theorem. You know, look at that long back, so 50 years back. Those were the days we had theorems at 8th standard and the proof also. But now if you look at the latest books, even books from NCERT, they are avoiding proofs of the theorems. Only they will give examples as the proof. I think that's not good. So that when I came to 8th standard, there was a theorem that if you have two triangles, A, B, C, other one is A dash, B dash, C dash. AB is equal to A dash, B dash, AC is equal to A dash, C dash, and other one is BC is equal to B dash, C dash. If three sides are same, corresponding sides, then the true triangles are same, congruent. That theorem we had in 8th standard, we had the proof also. Nowadays, proofs are not there. I think Dr. Rajput knows it very well. He is a publisher. He publishes NCERT textbooks. So we are more interested in Indian history than in mathematics. Yeah. So then what was the conclusion was, I mean, this is a conclusion I found on my own. That is, given three sides of a triangle, this triangle is unique. So therefore, you cannot change the shape of a triangle, however much you do it. And the proof and all, my teacher explained the proof, and it was asked in the examination. We solved it, and we got some marks also. So I think that was the real aesthetic experience for me. And suddenly, what cannot happen for quadrilateral, it happens for a triangle. It was an aesthetic pleasure. So I think that's an aesthetic experience, and in mathematics lab, I think there's the right place where we can have this aesthetic experience. I think there is one way of measuring aesthetics. This is given by Gelfond in 1959. The formula is M, capital M is equal to O divided C. M means measurement of aesthetics, O means harmony or order, C means complexity. Now look at this, it's a beautiful formula, though it doesn't appear to be non-mathematical, but a lot of mathematics in it. But if the complexity is very high, if the complexity comes very, very near to infinity, then what is happening is, if your order is fine, but then aesthetics is almost zero, no aesthetics at all. That means when there is complexity, you don't have aesthetics. If you keep complexity fixed, and then your order is high, then you can see that there is more aesthetics. That means if there is harmony or peace, then a lot of beauty is there. So it conveys a good meaning that how we can measure. The measurement could be in a scale of 0 to 5 or 0 to 3, something like that. So then coming to this fundamentals, this fundamental is one thing which is troubling us, both in books as well as among the teachers. Yesterday, I think Professor Manjul Bhargava was telling that teachers do not care for fundamentals. He gave, not only that, he also spoke about beauty and all that thing. It's a big thing. So, in a fundamental, this was a question I asked to at least 1,000 teachers in workshops at RI Bhopal and RI Mysore. The question was asked, the first question was, why the product of two negative numbers is positive? In short, I asked why -2 into -3 is +6. Second question is, what is the number after half? And the third one is multiplication a repeated addition? Not a single teacher answered. And that only proves that our mathematics teachers at secondary level, they do not understand mathematics. The reason is the lack of fundamentals, right from the top. So the fundamentals, the textbooks do not take care of fundamentals. Though in the national curriculum frameworks we talk about fundamentals, but there is no implementation formula. So these things are there. So fundamentals do matter. I think we as the teachers will have to care for fundamentals, and proof is a fundamental. So fundamentals will have to be taken care, and the kind of research in mathematics education is going on. I think we need to more do on the fundamentals. Why fundamentals are failing? So is that the reason for failure of students in these subjects and all that thing? Is that the reason for creativity getting reduced and all that thing? So it's a scope. There's a scope for doing research in mathematics education. But let me also tell you about this use of computer. Many people think that that's going to do some wonders in teaching of mathematics. No. If at all anything is going to teach, it's only the traditional way of teaching using fundamentals and giving values to the proofs and use of blackboard. So let me say one thing in short. That is, there's a famous four-color problem in mathematics. And this is a problem some 150 or 170 years back. The problem is, there is, I think, some shepherd or somebody invented that problem. That is, you have, suppose you take a circle and take another circle, bigger one, you make 4 regions. Then you need 4 colors to color that region in such a way that adjacent regions should not have the same color. So if you take that 4 regions, you need 4 colors. Similarly, if you take South India, to color the states, you need 4 colors. But you will not need more than 4 colors to color any map. That was the 4-color conjecture. Ultimately, it is solved in 1976 by Apple and Akin using 1,200 hours of computers. Now it's reduced. Now it has come to 60 hours or so. Maybe it will come. But the point is, what if computers err? Because computers can err. The reason is because the computer is made of chips, which are all chemicals. So there's a chance. You can see that many times your mobiles, suddenly some other number comes. And these chips have a life. So what if the computers err? So we don't have a computer-free proof for this one. If Professor Devi can get a computer-free proof, she will get 2 Nobel Prizes. Of course, there is no Nobel Prize in mathematics. There's a field medal. So Professor Manjul Bhargav is a field medalist. It's a big honor for India. He's an Indian, settled in America, Princeton, and he's basically from Jaipur. His father went to America, he also went to America. He had all his education in America. So coming to the last one, this is the addition. Now, this y minus 2 into minus 3 is plus 6. I think if anybody can get me the answer, I have my number. You can ask Tulika, she would give you the number. So I have a proof. I'll send you the proof. Proof is only, it uses 2 important things. One is the distributive law, what we call the taking common. Other one is a plus 0 is a. So that's what it uses only these 2. That's called additive identity and distributive law. And one can easily get those proof. And come to this dynamic experience. Dynamic experience is my own experience also. In experience is is an actual participation in or direct contact with a educational activity. And educational activity is related to education. It has to be positive, and you have actual participation in an educational activity, actual participation, and also direct contact. It's not indirect. In experience, you have always direct. So, experiences, that's one meaning of experience. We'll not get into the definition, but if you feel it, it's fine. Experience will become dynamic once it's continuous. Means there are no checks in it. It goes on, no static and all that thing. All of us, most of the times in the classrooms, we give a static experience. Static experience, we ask a question without waiting for an answer. Over. Or I think when I was in Ajmer, I went to some schools for internship. There's something called two-part method. I don't know whether it exists now. Two-part method means the teacher would ask first student to start reading. Stop. Next, you continue. Like that, that's called two-part method. But that's not a good method. But these are there. So, but that's not dynamic experience, nor even a good experience. So dynamic experience does matter these days. And though we mentioned these things about NCFs, we had many experiences. I think in 1975 we had one in NCF, then we had in 1888 one NCF, then 2000 we had one NCF, and 2005 we had one in NCF. The present one is 2003? 23. 2023 we have another NCF. In all NCFs, we talk about aesthetics, we talk about dynamic experience, we talk about feelings, we talk about concentration, all sorts of things. But the problem is, we don't have any implementation strategies, nor our NCFs reach the schools. We did a survey in the NCF 2005, and we also paid 10 lakh rupees to each state to develop their own national curriculum framework. Except Bihar, perhaps, not many states have done it. Gujarat refused it. So, the NCF doesn't reach the teachers, NCF doesn't reach the schools. If you ask anybody, any student, they don't know anything about NCF. If they ask you what is curriculum, they say it's syllabus. So these are the things. Curriculum has a direction. So let me give two examples to close of this dynamic experience. One is an internship in Kerala. I think that was in Cochin. I had gone there in a school. One of our B.Ed students was giving a lesson. What was the objective was the sum of the angles in a triangle is 180 degree. And in fact, a good teacher should start with that thing. This is not always true for all triangles. Only if the triangle is drawn in a plane, yes. But if there is edges or curved ones, the sum need not be 180 degree. It will be more than 180 degree. But what that student did was, the student distributed 10 triangles to 10 groups of students. The group of 3 students measure the triangle. So she made a table, and first group said that 179, second group said 181, maybe another one is 179 plus 0.5 and all that thing. So then she asked, what is it? Some said that 179, somebody said 181, Then she said, is it not very close to 180? Yes. So the proof is the sum of the angles in a triangle is 180 degree. But that's not the right thing. Either you give a proof which is simple, or you can have take that paper and then arrange them in a straight line which is 180 degrees. So this is the thing which is not a good experience for a teacher and good experience for the college also. The second one is a good experience. So this is exactly explained it now. That the two triangles are same. So that was an aesthetics for me. And last one, I think those who are teaching at 11th standard, there is something called the calculus. You got a differential calculus and also integral calculus. And I will not go into the details, but there's a fundamental theorem of calculus. What that fundamental theorem of calculus says is, on one hand, you have got an area, which is integral. On the other side, you have got a slope of a tangent. And the beautiful thing is, these two things are connected by fundamental theorem. Area is connected to a slope of a tangent. Nobody could have imagined it. But that does happen, and they are same. Area is the same as slope of a tangent. That's a real joy of aesthetics. And I think in our classrooms, there's nothing wrong if some of us use aesthetics as a method of teaching. They can have their own ways. The aesthetics changes from person to person. You can have many things and use maybe once in a week or once in 10 days aesthetics as a kind of strategy. And it's not difficult at all. It is everywhere. Aesthetics is there in music. Aesthetics is there in poetry. Aesthetics is in beautiful flowers. Aesthetics is there in this one. So at the end, I would only say that aesthetics does matter for all of us in life. Aesthetics is the center of education, and education is center of democracy. By democracy I mean by the people, for the people, of the people. That's what the famous first American president told. So thank you very much.
So if you have any questions, further more questions?
No, before I'll take 5 minutes. So these questions, Professor Rajput, there's something called index of teaching. I have mentioned it here. So index of teaching means the number of questions asked by distinct students in a class of 5. And this is the simplest way of finding whether the learning has taken place or not. We conducted an experiment in Sandur, Karnataka, near Ballari. So that experiment was that 10 schools were given to us. There's a Gorpade was the king there, his group of schools. So we went to 10 schools and found out, sat for 45 minutes in the class. So 2 days. We hardly saw any students asking questions. Then, after discussing something and all, 1 or 2 classes, there were 2 students asking questions. There was 1 class, there were 3 students asked questions. So, we 4 of us from RI, Mysore, we discussed and came to a conclusion. This index of teaching, what we called it as the IT. IT has to be at least 5. If it is at least 5, it means learning has taken place. And it's easy to evaluate. You don't have to do many things. And it works well in continuous and comprehensive evaluation. Yeah. Now I don't know, it's a forgotten concept. I think in 72 or so, it was a big concept, and it was found in NCERT only, and first implemented in Rajasthan. Continuous and comprehensive evaluation. Thank you. Yeah, the diagram is here. Those who want, they can take this and give it back to me. Yes.
So please be seated.
नहीं वो क्वेश्चंस पूछते हैं तो ठीक है. अरे ये ठीक है.
Okay, yes please. So mic जरा उधर audience को भी दे दीजिए if they have any questions.
Here also one is required for sir.
Kritika,
I am loud enough.
ask questions.
I don't need the mic, but yes.
Sir, please be seated, sir. We will make the
अरे नहीं जी, this is fine. No,
If you are comfortable there.
no, it's fine.
Yes please.
Good morning, sir. I'm Kritika, research scholar from Central University of Kerala and also the alumna of RI Mysore. Sir, what all the things you said, like the concentration or dynamics, all the things, it differ with each students also. Like now, how to measure is there will not be any measurement, or we can scale them it like they will be having, and the teacher will not be having, as you have already mentioned, like it cannot be taught. Concentration cannot be taught, or the feelings cannot be taught by the teacher. Then how do we include all these in the classroom from the beginning to get the feeling from the students or the concentration from the students? And how could we include this in the school curriculum then? The dynamicity, all the things are like, yes, maybe now as a research scholar I could feel that, but from the school level for the students, how we could make them understand it or teach them, or what is the way we could use?
Yeah, the teacher has to do only a little bit. See, the feelings come from the culture of the family, because they have that feeling. Every community has different kinds. I mean, same feelings. I mean, the feeling, you may not define it, but you can say that you love mathematics. This is how mathematics is loved and all that thing. I think that feeling, love and all, they understand.
Yes, sir, that I could understand. But when it is in the national level, national curricular framework, it should be implemented throughout the country. So, like as you said, like the students coming from different background or their family or those cultural things affects, then it differs. That was I'm saying. It is diversified over that. Then how the same concept of concentration of mathematics or the same feeling of mathematics could be inculcated among the students. That was the thing, the commonality I was trying to figuring out.
Commonality is an unwanted thing. You don't expect it, because the diversity is the most important thing. Mathematics or any other subject, even for any culture, because diversity is inbuilt in our culture. So let's not get into this commonality. See, the common curriculum, common school education, all this, they have failed. But the implementation is a problem. Though we had so many NCFs, but we never mentioned a implementation strategy. It's difficult, perhaps. So, but it could be done at the school level. We need to have a curriculum at the school level, local curriculum. The school should have an autonomy to have some small changes to be made. But when it comes to feelings, the students do understand what is love, what is affection. I think they know how to love mathematics. If at all they hate mathematics, that's for. Let me also say this: hating mathematics and all possible, but mathematics is a difficult subject. I understand, but mathematics is difficult not because of abstraction, which many people think. Abstraction, even a 2-year-old baby will understand the love of mother. Practically no problem. They understand that abstraction of love is there. But mathematics is difficult because of precision. Precision means either true or false. That makes mathematics difficult. In fact, that's what even Einstein also told. Precision makes mathematics difficult. Yeah. So, difficulty thing is there, but when you love mathematics, you feel mathematics is easier to understand. So, love matters. That's how the feeling. The feeling is sort of a culture. But when it comes to concentration, difficult to teach concentration, but concentration comes, every family has their own bhakti. They have a way of prayer and all that thing. The prayer is essentially a concentration. When you pray God, I think there is some concentration in it. I think they learn this concentration from the parents, and teachers can only tell in the class that did you pray today? Did your parents ask you to pray and all that thing? I think that's how the concentration comes. But these are all things which cannot be taught. They can only be passed on from the culture. Okay.
Thank you, sir. Any other question? Only one question will take up. You please. He was first person. Yeah, Gandhar. You introduce yourself and then ask your question. And question should be brief so that answer will be loud.
Sure, sure. Thank you for your talk, sir. So my name is Kumar Gandharv and I am a PhD student at Central University of South Bihar. So, sir, I am going to ask a question about these mathematical tricks. Nowadays, with the rise of technology and the cheaper rates of internet, the YouTube is flooded with all the videos of mathematical tricks. And it has reached to such level that children are also making videos on mathematical tricks. So I see it as spreading like a pandemic. We do interventions in the classroom, but outside the classroom, the child is playing with tricks. So how do you see this? How do we counter this challenge?
Yeah, I written in this paper. So I written that blackboard versus computer-aided teaching. Because now even in our national curriculum framework or even your NEP 2000, we are given more importance to this computer-aided learning. But it's a problem. See, even today, though the blackboards are more than 5,000 years old, we have an evidence for that thing. Blackboards existed 5,000 years ago. So, the advantage of blackboard is when you write on the blackboard, the students have a time to think. So, the thinking takes place. But whereas you have got a PowerPoint presentation or some other computer-aided teaching tool, then they don't have time to. In fact, we are not advocating that we should use PowerPoint presentation in the classrooms. It's only when you want to say that a sphere is generated like this, or a cone is generated like this, sea looks like this, earth is round and all that kind of things, so then perhaps those tools would work. But blackboard even today is most important thing, and what blackboard can do, computers cannot do it.
One question we can take from this side. Yes, only one.
It is there in my this booklet, in this paper. It is there.
Good morning, sir. Thank you, sir. So, sir, I am Selvakumar from Krishnagiri district, Tamil Nadu. Sir, actually, my question is how to focus on the curriculum. Actually, we are a teacher, we are focusing only on the syllabus. We are hurry up to finish up the portions. As we are in the class 10, we just finish the portions within the span of 6 months. But actually, I know that we are not able to give the basic fundamentals and we are not focusing on the curriculum. So this is my question. Thank you, sir.
Right. No, I understand your problem. But I don't know whether you know about Krishnagiri or not. Krishnagiri has one of the largest farms. Many of the mango saplings are available there.
Yes.
I have planted 1,200 mango trees in my ancestral village. I bought all of them from Krishnagiri only. So that's the Krishnagiri. But see, I understand the curriculum is not understood and the syllabus only is concentrated. Of course, curriculum also we should understand it is like a vector which has got both the direction as well as the stuff. So if you can, it has the curriculum has got both content which is syllabus and then a direction. I think the direction cannot be defined in the curriculum. We can say that this is a particular direction and all that thing. If you want to define a direction, again you will have to come to vector space in mathematics. But direction, take intuitive meaning of it, and it all depends upon the teacher only. It's only in 10th standard and 12th standard you have to worry about the examination and all that thing. The rest of the classes, the teachers got the autonomy, they can have the examination their own way and all that thing. There's nothing wrong giving importance to the fundamentals. You don't have to finish the entire syllabus if you finish it is good, but there is no condition as such. So you can give the test the way you want, you can touch the fundamental the way you want and all that thing. Ask questions why -2 into -3 is +6. You ask can multiplication be replaced by addition and all that thing. Let them give a counter example. Ask, Goldbach's conjecture. Goldbach's conjecture, what it says is, if you have any even number other than 4, it is a sum of 2 odd primes and all that thing. If not, ask them up to 100 primes, let them find out. Some such things, not necessarily from the syllabus, from your own way. You have a total autonomy in the class. I don't think anybody else can dictate you.
Thank you, sir. Thank you, sir. Thank you very much. Thanks a lot, sir. You may please take your seat. And it was a very nice discussion. I must pay my sincere thanks to Professor Ravindra for making such lovely presentation on talking on various issues related to teaching learning of mathematics and also the present circumstances in our country.
Very pertinently he answered the questions which you have asked. There will be opportunities when you can talk to him maybe during the tea break, because we are now having lack of time, so we are not going to take much of your time because next session is to be started. As being chairperson of this, I pay my sincere thanks to Professor G. Ravindra ji, and as he has mentioned, his paper will be available to all of you. Is it? Yeah. It has been already circulated or printed in that booklet? Okay, so you all will get this paper, so we are not summarizing what he has already spoken. You will get it. Yes. You will get the paper. And kindly read the other documents also. As you mentioned, curriculum and syllabus. Obviously, majority of the teacher do not know even syllabus. Curriculum is far away. Syllabus, they know only the textbook. So, and they are considering the textbook, finishing of textbook. Whereas now the major focus is on competencies. If you see, we have started talking from 2005 onward that the education should be competency-based education. So teachers should know the competencies, and these can be inculcated and developed through many material, maybe many resources. One of them is textbook or the syllabus. Other is you as a major resource in the classroom, as Professor Ravindra has already mentioned, that you have to do it at your own places. As teacher, you have lot of opportunities to bring what you asked. She asked how concentration can be brought. This is the pedagogy. If I am narrating a story to a child will not look toward anybody else until that if that story is very interesting and is narrated very well to the child. Similarly, the classroom transactions, if they are very good, children will have concentration. If these are not, whatever you are teaching, this may be a very simple topic or maybe a very, very difficult topic. So mathematics is not difficult. Difficulty is teaching. We are making it teaching difficult. So fault is with the teacher, not with the curriculum or the syllabus or the subject. Thank you very much, and maybe a vote of thanks.
Thank you, Madam, for giving me this opportunity and once again getting an opportunity to share my space. It was indeed a very pleasant listening to Professor G. Ravindra again on the art aesthetics part of mathematics. I would also like to thank Sir for throwing light on so many aspects. Sir was talking about concentration, developing concentration, feelings, aesthetics, and the dynamic experience. He also talked about, yes, so much on concentration she also has raised, and it is so very relevant to the national education policy. It talks so much about integrating sports, games, or music, dance, art, which promotes concentration. And Sir was so relevant when Sir talked about developing concentration among students. And this is something which I thought, and this is reflected in the new education policy that we are all talking about. So that is one thing, and the other thing that I also liked is about when he talked that aesthetics is at the center of the quality education. Yes, we just cannot say that we are from science or from mathematics background and it is not about aesthetics. Yes, there is so much aesthetics all around, and mathematics is a source of measuring this quality, the aesthetics, and which is at the center of all. Also, when Sir talked about index of teaching, and I could see that Sir said that if there is a number of questions being asked, from there we can understand that the learning has taken place or not. And the questions that came up reflected that all were so attentive and so much of learning has taken place. Thank you, Sir, for bringing out such an interesting topic to discuss over here and throwing light on it. And I also thank Professor Anup Rajput, Sir, for being such a good chairperson to this session. I thank our principal, all the participants, student volunteers, and my head too, and all the advisory members for being present here and taking part in the discussion. Thank you all.